All right, welcome to the Protein MB podcast. I'm Jordan Sisiwa, and we're your source for sustainable protein. We are a resource ensuring that this province knows what's going on in protein and getting that message out to the world. And of course, when we do that, experts are who we like to connect with. And because this industry is so small, some of those experts I like to call friend. Today is no different on that one. Dr. Dylan MacKay. Uh, Dr. MacKay, why don't you start off by just telling us who you are and how you got started in the research industry?
Thanks, Jordan. My name, Dylan MacKay, not to be confused with a character from 90210, but I guess my start in the nutrition research field goes back a long time. When I was 13, I was diagnosed with type 1 diabetes, and sort of that kind of shaped my life to be really focused on nutrition. And that sort of probably set the stage for me to move into some type of nutrition related field. But how it evolved, after high school, I had an interest in biochemistry, biology, chemistry. Those were the courses that I really liked in high school. Went into biochemistry in an undergraduate. And the topic there that kind of appealed to me was nutrition because, it's biochemistry that's happening in our body every day, every time we eat. And it also had that tie in with my own health. The more I understand about it, the more I could understand about my diabetes. Originally thought I might want to go into medicine, which is, common for people who have type 1 diabetes because we have lots of interactions with medicine. And then I didn't get in the first time I applied to my hometown medical school in Newfoundland, and I was looking at some other options. One of the professors I really liked in a biochemistry class was doing this cool research, looking at different diets for in pigs and growing them out and seeing how different diets related to chronic disease risk. And I got a summer internship with him for that summer, and I really liked the experience. I really got to enjoy the research, and he invited me to do a master's program with him. And that master's program was just amazing. He and his wife were my supervisors, and they had a lab. It's Dr. Bertolo and Brunton at Memorial University in St. John's, Newfoundland, and at that stage, I was like, I want to do this for the rest of my life, kind of thing. Had to look into it. If you want to become a professor or a researcher in nutrition, it's typically a PhD research type thing or a master's at least. Exploring the options from there. I did the master's. There were some industry work options with a master's, but I really wanted to continue. My goal was to be a professor, so I came to Manitoba, did a PhD at the University of Manitoba. From there, there were options again after the PhD to go into industry positions because, that's available, but I stuck with the academic route and sort of chased that dream, which is not the main outcome of a PhD, but it's more one of the rare ones. And I was lucky enough to get some postdocs. That's sort of where you're hired to be a professional researcher, and you do research with for other professors. And eventually, lucky enough to get a position where, I guess the research that I was doing for others was good enough to get it that somebody hired me to start running my own research program. So.
And I love it because I love the roadmap. And this is something that in conversation, I think, and myself included, because depending on where you grow up, not a lot of people were coming out to Steinbach, Manitoba, to discuss research and potentials there. And I know for me, we met. I gotta say, it's going back 8 to 10 years ago. You did a DEXA scan for me. I opted into one of the research things you were doing, and you did the DEXA scan. You also asked me for a stool sample that I had to go home and take, which I guess those awkward moments in your career where you're like, we need this information. How are we going to get general populations to do it? But this going down that path, can we chat a little bit on on the projects you've worked on, because your career has had some pretty impactful research, and this is, something. One of my plans with this Protein MB project is to get a lot of youth thinking, is to get parents thinking of career paths that don't necessarily make it to the public eye, right? Like we know what doctors are, we know what teachers are. There's these certain paths that are laid out for you at the end, but I think the creativity of a researcher gets missed in conversation. So if we can talk a little bit about what you've done, I would love to hear more stories about the projects you've done.
Yeah, so I mean, I guess creativity is key there, right? I just always really like the idea of finding some things that aren't known in an area and like really nerding out on them and trying to find the best way to answer it. That's sort of what's directed why I do clinical trials now. I think it's because there's lots of different levels of research, and there's lots of different questions within each of those ones. You can do research in cells, you can do research in animals, but for me, a lot of that always builds to research that, we're doing the research for the most part in health to benefit human health. Now, there's lots of great research in animals to benefit animal health and the ag industry, and I overlapped a lot with that because there's a good overlap between nutrition, biochemistry, and animal sciences. But for me, I went after the human health because of my connection to diabetes and stuff like that. But it was really creativity and sort of following along a path that may not have been as clear and opened up as it went along, right? There were quite a few stages along the way where I had to stop and think, well, oh, should I go for this job with this company or should I continue at a university? Yeah, it's the same conversations I have with all my students now about, before I even invite them in, I, talk to them, why do you want to do a master's? What are the stages do you want to be at afterwards? Or why do you want to do a PhD? What are you looking at and thinking about afterward? In each case, I think you develop these great skills around, how to communicate verbally and in written format, how to ask good questions, how to design good experiments that'll hopefully answer the questions you want to ask, and so I was lucky to be able to follow along that to where I am now. It's kind of flattering to hear that I've done much impactful work. I still am considered an early career researcher in many ways, although I have been I guess independent since 2008, which is pre-pandemic. So that's like decades ago, right? I don't even remember that time, but it's it's been really an interesting journey through that too. I started my PhD in this area called nutrigenetics, which was sort of looking at like genetic variability and response to different foods and nutrients. But for me, that was sort of not really hitting it. I was really interested in sort of in looking at that variability between people. I kind of started to think there's a lot more bigger factors that impact health, and so I started thinking of more like socioeconomic factors and wanting to do things that are less individualized in nutrition interventions. But along the way, I really was interested in clinical trials. So we were. You kind of think, you look at where there are gaps in the literature, like where's a new food product, where's a new food ingredient, maybe a new source of food, commodity, so some of the earlier trials that I did, we had hemp coming in, right? It's a Manitoba story. It was really driven by a Manitoba harvest, changing the laws to grow hemp as a food source in Canada because of the prohibition. Back when cannabis wasn't even legal, and then hemp wasn't even legal, right? To grow it as a food source. And even though there's a long historic consumption of it, when it came out on the market, there was no trials that had ever really done, nobody ever really fed hulled hemp seeds or even tested out some of the hemp protein shakes in clinical trials. So myself and some colleagues were actually able to do some of those first trials, just testing out how they compare to something like a soy protein that was already on the market. And there's nothing particularly scientifically novel about that, except it wasn't done before, and we should compare them because it's something that a consumer is going to be seeing on the shelf and maybe wants to know, hey, if I'm a vegetarian, maybe I've been using soy protein as my protein source before my workouts, do I have to worry about switching to hemp, or is it reasonably equivalent in terms of how full I'm going to feel, or the protein quality and stuff like that. And so the hemp came from that idea of just no one had done it before, but really a lot of the times you come up with questions by looking at what other people have done or what's missing, and then just making that next little step, right? Everything that happens in science is sort of building on all of the other knowledge that's there, and it's evolving, right? There are no necessarily like scientific facts. It's always the scientific consensus that's evolving within a field. It can change. It actually should change as data evolves. You do end up with enough data in many areas where it's not worth spending any more time on, because that consensus and that evidence is there. But in most areas, we're learning more and more, or a discovery in another area unlocks other discoveries in something that we thought was more established. And I really like that about science as well, and research is sort of constantly something new. So that just hits the right interest for me in my brain, I guess.
Let's stick here for a while, because this was actually, when the team here at Protein MB was discussing podcast ideas, this is something that really resonated with me. And like, one of the first things that I said is I want to sit down with a researcher and talk about the scientific method, because I don't think that it's as Google became a larger staple in people's lives, and the ability to go and quickly get answers to any question. I think what I've seen is just a lack of understanding on how researchers work, and that being, like you said, there is a team makes a proposal, they create their experiment, they do their experiment, however long that process might be, maybe the week, the month, the year of doing
Years.
this kind of years. That research is then put out there. People recreate it. They also might recreate it by saying, okay, you came up with some solutions, possible solutions. Can we modify this slightly to go to the next level? So now that I've completely confused the idea, if you can take it and for the general public, if you could say, this is what people need to know about the scientific method, so that people can be informed on what is fact, what is consensus, and how next steps come about in the science world.
Yeah, I mean, I guess it'd be almost, you can't really say, like, fact's a tough one if it's like unchangeable, unmodifiable. And I think that's a real translation and communication issue sometimes, that we had great examples of during the pandemic, where the consensus changed and people suddenly stopped maybe trusting science as much as new evidence came out and evolved, right? Especially around, like, at the beginning we didn't know about, or there wasn't scientific consensus that COVID was a particulate airborne type thing, right? So we were using lots of hand sanitizer and gloves and all kinds of stuff, wiping down groceries, when filtration and masking and stuff, that was likely slightly better. But that idea that many scientists don't speak with a huge amount of confidence, and because we have that built in. I guess it's not. It's kind of like a distrust, or an acknowledgement that the evidence may evolve and change, is tough in communicating, because other people who may just say, like, oh yeah, this diet's going to be the best you've ever had and it'll make you healthier because look at me, I'm jacked and I'm super healthy. That comes across confident, but the truth is that there are probably no one diet, and the diet that makes one individual the healthiest may differ by, where they live, who they are, what their jobs are, like all kinds of different factors. But when scientists try to communicate, we don't have that certainty because we live in a world of inherent uncertainty, right? The way we do the science and the scientific methods, we come up with ideas or hypotheses, and we say, hey, maybe, hemp protein might be just as, we'll start with a project and say, well, we got hemp protein here. We think it'll be just as equivalent to soy protein based on its properties in making you feel full. And then you design a trial or some type of research to answer that question. You get the results, and maybe you find that they're pretty much the same. And you put that out there, and then some other research group recreates or expands on your trial, does it bigger or better, uses better methods, and they may show, oh, actually, this one's slightly better, because their design might have been more precise, or been able to measure something a little more closely than the previous design, and that's just sort of how the evidence evolves, and that leads to scientists not communicating uncertainties, which is a disadvantage. But I think the public needs to know that, the individuals who do communicate in absolute certainties can probably be ignored because most of these facts are actually shifting. As we get better at measuring things, as we get more data, you want to stay at the edge of the scientific consensus.
And I think it's this is a perfect time in the podcast for me to remind you that you're welcome to be your funny self and speak how you want. Because I remember the first time you ever clarified this for me, and when you said, you'll get a lot of these influencers and kooks out there in the social media world who are just quick to just, because, like you say, they look good. They'll say, well, this is what I did, so it's scientifically, this is the thing you need to do, and I'm sure of it. Whereas your best researchers are confident that they can find some answers and some best practices, but you will never have a researcher who's credible come out and say, this is the answer, I am confident, and roll with it.
Well, I mean, I'm sure there are some researchers that'll talk that way. I hope to try and avoid it, but it's really about that certainty. And like you said, I mean, it's kind of, we want to trust people who are certain, because sometimes we think uncertainty is someone might be lying or untrustworthy because they might be changing their story. But in science, the data is always evolving. So that those individuals that are speaking with absolute certainties, I mean, I can just, they're probably trying to convince you of something. And in that, the health influencer field, they're after your time for their advertising. They're after your clicks for their referrals. They're after your money to buy their books or their videos or their consultations or their supplements, that kind of stuff. And you see it in the language that they use, because they're competing, they're selling themselves and a product line and a lifestyle, and they have to be certain with that. Otherwise, the uncertainty doesn't necessarily sell. Outside of a couple of ones that's their brand as well, where they are hopefully sticking to scientific consensus, and then there's blends in between where people will talk sort of with certainty using scientific evidence, where the papers don't really back that kind of stuff up, right? So they'll say like, oh yeah, blueberries are the best berry because of this study, and then you check it out, and the trial basically said blueberries were probably better than like chocolate covered raisins for something, right? And that's the kind of thing that you see sometimes in nutrition, because how nutrition gets its funding often sometimes has influence from industry and groups that have agendas and business agendas and ideas about what the results they want to have are, and then of course researchers also have their own biases and beliefs that influence their work. And so that's why it's important to like look at a consensus of groups of researchers, because let me tell you, when a bunch of us get in the same room, the coming to consensus is difficult. Every word is argued over, and we're not in there just saying like, what's the best way to, we disagree, and we come to a consensus that may make everybody slightly unhappy, but that's probably the safer consensus because it's less likely to be wrong and also less likely to misdirect people.
And I think that that is something, continuing that path. Um, I've I've had the joy of watching groups of scientists and researchers um, in a setting where, from the outside looking in, you're like, these people are not getting anywhere. There, like, and you can even get like, I don't want to say shouting matches, but you can get people that are very passionate. But when you see it from the outside, it looks like arguments, and it looks like we're not moving in any direction. But if you were to give them an hour or two, when you come back, what they've got is, like you're saying, a consensus. But and what they've done is they've defined as they went along. When you say the best of, or when you say should be done this way, they'll argue what point you've made with their research, and then the next thing you know, there's that
They
consensus. But it's from all of the research making a decision at the end, and it's just a bunch of people that have nerded out over the past 10 or 15 years on a topic
Yeah, well, I
wanting
mean,
their
you can say shouting. I've seen that happen at conferences, and it is passion when you have been researching different topics for some people 40 years, right? Then you've got strong opinions, you've got lots of knowledge, and that consensus process can seem slow, but you eventually hopefully come to statements that everybody is sort of happy with or will accept. I recently worked on the new Diabetes Canada remission guideline chapter for type 2 diabetes. And let me tell you, at the outset, we had a lot of authors, and we all had different ideas about this topic. And it took us 18 months to come out with that chapter. We worked, every word was debated, maybe, should, like, to get that consensus. And I think that's an important process, though. There are clear guidelines and methods to coming to consensus to assist in that, to make sure that one person's not driving something. And I think those are important things to look at, right? Because you don't want to just trust me too. I mean, like, I make all kinds of mistakes. That's why you should have a group of us. It's a human thing where we all make mistakes as well, and we all might have biases, and so consensus is really the important thing there. You want to look at the overall research field when coming to make an answer, but that can be very difficult, right? Because if an individual is going out and trying to get an answer about, like, hey, should I eat tomatoes or something like that, then they'll find a bunch of studies that show tomatoes are good, and then they'll find other studies that show tomatoes are bad. What tends to happen there is you end up with an evolution of the quality of the evidence. There's this diagram that's used as sort of an evidence pyramid, where you have anecdotes and observational data at the bottom, and then you have something called prospective cohorts. That's where you follow people over time. Prospectively is the next level of evidence. Then you end up with interventions. So those would be things like randomized controlled trials. That's what I specialize in, where you take individuals and you test an intervention, hopefully versus another intervention, and measure outcomes in more of a controlled way. But that's not the top of the pyramid. The top of the pyramid is then what's called a meta-analysis and systematic review, where you hopefully ask a question, you look at the entire research literature that's there, and then look where that falls. There's different methodology to combine it all, and you come up with sort of where the field is in the consensus. That's also, those types of meta-analysis and systematic reviews also tend to be the best way to identify what are the next steps, what are the limitations of the existing literature, what areas of this field do we need more research on, or so that's really when people are looking for answers. Individual trials, unless they're really big and groundbreaking with thousands and thousands of, or tens of thousands of individuals, you want to look at the consensus of multiple trials in these systematic reviews and meta-analyses.
fascinating. So
Yeah.
basically, like if I if I have an idea in my head, or if I want to go and find out just about anything, I can go. What's it? Confirmation bias, right? I can go out there and I could probably find in any given situation, from how to raise a child to what foods to eat. I can find someone that's going to share my ideas, and I can find multiples.
Yeah, that's
But if
100% it. The big thing the idea of cherry picking. If you gave me a topic, like with an opinion, and asked me to find research for it, especially in the area of nutrition, you can pretty much pick strong arguments and make it seem like it's very well supported. But the key thing to that top of the pyramid is that systematic, right? Systematic, where you do the entire literature rather than precisely picking the things that support you. Hopefully, that's what's happening there, where you come up and you do a search that captures everything. I mean, there are stages along the way, if people aren't doing it well, that still have these potential for bias, but even in these systematic reviews, they tend to have ways of looking at the potential bias in the other literature, or seeing if there's a bias in the field through statistical methods, where you can say, like, oh, it looks like there should be some trials that are negative here, but everything is positive. So maybe there's some people who aren't publishing their negative results. And you can know that through normal statistical distributions. Like, there's normal variability in all kinds of outcomes. But if you only have half of a distribution showing up, then some people may not be publishing the other part. So, yeah, it's a whole field in itself. It's called knowledge synthesis and translation, and there are scientists that's all they do is they answer questions from the entire field of literature, and then they get very good at evaluating the strengths of those of the evidence they find in the literature, and combining it to help answer questions. That's how most care guidelines in medicine are hopefully being built these days.
Fascinating. This is why I love discussing things with you. It's fascinating to hear how answers come about. Now, with that said, and the last thing I want to chat with you about is a little bit what's upcoming from you, because I know that it's not going to be specific to the protein industry, but a lot of what you do, I've followed for years, because it's always got a solid backing into humans and human health. So if you've got a second for us, let us know what you're up
Yeah, well, I mean, okay, so it's quite a long list. I mean, on the Manitoba side, right now we have some trials running where we're looking at food products and novel food products made from wild rice. We're working with an Indigenous-owned company and some First Nations groups, and Protein Innovation Canada on some projects related to wild rice. That one's sort of just looking at glycemic response of wild rice-based products and wild rice versus white rice and brown rice. So we feed them to individuals. We see if their blood glucose goes up the same or less or more, that kind of stuff. That's on wild rice right now. My I guess my favorite project at the moment right now is in an area of nutrition and chronic disease. I get to work with a lot of nephrologists, so people who treat individuals with kidney disease, and how we come up with a lot of our questions for research often involve talking to people with the lived experience of the conditions, so individuals with chronic kidney disease, and then talking to people who treat those conditions. And so this project evolved from that. There's a condition in chronic kidney disease called metabolic acidosis. It's basically when kidney function decreases. It's the place where our acid-base balance in our blood is basically maintained, because it pumps out acid in urine, and as that decreases, some individuals have issues with that. And the tight acid-base balance in our blood is incredibly important, because when that goes off, it affects all of the biochemical reactions, because they're pH dependent. So if it's too acidic or too basic, all the proteins in the body can sort of change their shapes and not function as well. So our body has a great system using bicarbonate as a buffer to keep our pH tightly regulated. As kidney function fails, that can fail for some individuals. They get this metabolic acidosis, and the outcomes for those individuals are quite negative. It's associated with accelerated movement to dialysis, increased mortality, and The way we treat it right now is we basically give people baking soda tablets. And that's not a lot of fun. If you can think of a volcano experiment, imagine taking a bunch of those tablets all the time. It's got a lot of burden on the participants because there's a lot of tablets. They're big tablets. They're like grams. Lots of this baking soda that you're taking to neutralize the acid from your diet, because the biggest load or amount of acid that you get every day is from your diet. Most of that's from protein, actually. Just has to do with the fact that the amino acids contribute to your acid load. Now, I don't think we should reduce protein necessarily in chronic kidney disease, and neither do some of the nephrology researchers, because frailty is also an issue with chronic kidney disease, because individuals who are frail, have reduced muscle mass and strength, also have negative outcomes. So we were looking at ways of how do we reduce the acid load without reducing protein. And it turns out fruits and vegetables are actually bicarbonate equivalents, or they often have base compounds with them. And some research group in Texas had done a trial where they delivered fruits and vegetables to individuals with metabolic acidosis, and it was as good as the sodium bicarbonate tablets. In fact, it was preferred because the fruits and vegetables helped lower people's blood pressure, and then it had other benefits like food security type stuff. They actually intervened on the entire family group, because when they just gave enough fruits and vegetables for the individual who had the condition, it didn't work. And when they asked the people what was going on, they said, well, I shared it, right? I'm not going to be sitting at the table and eating fruits and vegetables with anybody else. So we were really lucky to get funding from CIHR, which is the Canadian Institute of Health Research, to try and sort of recreate that trial from Texas in Winnipeg and in Halifax to sort of set up a potentially larger trial. We're working with grocery stores and grocery, like fruit and vegetable companies, and we want to test delivering fruits and vegetables to people's houses, so removing as many barriers as possible, comparing that to the pharmaceutical, the capsules, right? Because in my mind, like you said, if I just tell someone to go change their diet and they don't have the means or capacity or time, especially if you have a chronic disease, like it's hard to do things. There's extra barriers, economic ones as well, that stop people from making lifestyle changes. We like to think that we can control our lifestyle. There's actually very little that we control in many ways, right? So we want to deliver fruits and vegetables to individuals with metabolic acidosis, and we're doing it for an entire year. And I'm really excited about that trial, because it's kind of a model for what I want to do for other populations. If we can show it works for this condition, I want to find other populations that have high disease burden and also high cost, because if you can find something, fruits and vegetables or food are not free, right? But we pay for healthcare costs in Canada, right? So individuals who move to dialysis, they cost taxpayer. There's a cost there to them personally. That the reduced quality of life. They may not be able to work anymore. They're caregivers, but it costs to run dialysis units, and those costs can be anywhere from like $60,000 to $220,000 a year. So if we can prevent individuals from moving to dialysis, then we can spend money on that and still save money. And so interventions, I think there are lots of populations in Canada like that, where we can give people the food they need, and if it prevents an expensive disease outcome, then it makes sense to me, right? Like, even if people are like, oh, it's super expensive, what are you going to give people free groceries? Well, yeah. I mean, if it's give them free groceries, if it saves us money, of course I'm interested in that, and it improves the quality of life, and it improves their health. That's the kind of stuff I want to do for the rest of my career. So, yeah.
And there that nailed it, because kids, if you're listening, or parents, if you're helping your kids try to track it down a path, what you just described there as a career, that helping, that ability to find answers and make the case for getting Canadians, our brothers and sisters that are out there in populations where they're at risk and whatever, getting them groceries and making a case that no one can say no to. Research is doing that, and that's the kind of stuff where I get jealous of your career, because
Yeah.
That's beautiful. That's the kind of stuff you can give a lifetime to, and that's
But
I think more
but what
kids need to know that.
what
Yeah,
you're doing is a part of that too, right? Translating those results. That's we need to have people who do that. And along the pathway, we have nurses, we have physicians that are working on the trials. We have masters and PhD students in nutrition research, clinical trial coordinators that work on these trials. We have health economists that work on these trials because we do the trial, but we have to have an economist look at how much were we spending on fruits and vegetables, how much are we saving in healthcare costs. There's tons of research all around those kinds of questions that are just looking for people who are interested in coming up with answers to questions that can help people's lives. So I think that's right.
um, Dr. Dylan MacKay, ladies and gentlemen, you are having a good time. I can tell. Best of luck with all the trials that are coming up. And I'm going to say it right now. You and I are going to have to sit down again because I don't even think we scratched. We didn't even talk about the pea protein pierogi that you made.
Yeah,
So
that's a throwback. But yeah, the pea protein pierogi, and we do have a hemp protein trial that's going to be coming out soon. That would be really good to come back and talk about too.
fantastic. No, it's got to happen because every time we chat, I learn something new. But there you have it for folks listening. If you've got a young person in your life that's looking for career paths, these are the kind of things that research can bring about. And for those of you out there that are looking for information or how decisions get made when you're looking at things that Protein MB is doing, when we look at research, Dr. MacKay just kind of filled us in on how that works, so that how decisions are made based on research. So again, Dr. MacKay, thank you so much for jumping on with us.
No, thanks for having me, Jordan.